Download this code from codegive.com, link in the description below. OK, here's a comprehensive tutorial on real-time streaming with Azure Databricks and Event Hubs. This tutorial covers the setup, configuration, code examples, and best practices. Overview. This tutorial will walk you through building a real-time data pipeline that ingests data from Azure Event Hubs, processes it using Azure Databricks with structured streaming, and potentially writes the processed data to another destination, example Delta Lake, a database. Key technologies Azure Event Hubs a highly scalable and reliable real-time event ingestion service. It acts as the message broker for your streaming data. Azure Databricks a fast, easy, and collaborative Apache Spark-based analytics service. We'll use its structured streaming capabilities. Structured streaming a Spark sql-based streaming engine that allows you to process data as a continuous stream using familiar SQL-like operations. Delta Lake, optional and open-source storage layer that brings reliability to data lakes. We can use it to store processed data. You can also use other data storage options like Azure SQL Cosmos DB, etc. Scala/Python will provide code examples in both Scala and Python, PySpark. Choose the language you're most comfortable with. 2. Prerequisites. Before you begin, ensure you have the following. 1. Azure subscription * You'll need an active Azure subscription. If you don't have one, create a free account. 2. Azure Databricks Workspace * Create an Azure Databricks workspace in the Azure portal. Choose a pricing tier, standard or premium. Once created, launch the workspace. 3. Azure Event Hubs namespace and Event Hub * Create an Event Hubs namespace in the Azure portal. Choose a pricing tier, standard or dedicated. Within the namespace, create an Event Hub. You can optionally enable the capture feature if you want to archive the raw data to Azure Blob Storage or Azure Data Lake Storage. 4. Storage account, optional. Create an Azure storage account if you plan to use the Event Hubs capture feature or write processed data to storage, example Delta Lake. 5. Databricks cluster * Create a Databricks cluster. Go to the Databricks workspace, click Compute in the left navigation. Click plus Create cluster. Cluster name * Give your cluster a descriptive name. Cluster mode * Choose standard for general purpose workloads or single node for testing, but note that single node clusters aren't suitable for production streaming. Databricks runtime version * Select a recent version, example Databricks runtime 13.3 LTS or later. These versions typically have better Spark and connector support. Python version * Select a version of Python if you intend to use Python. Autoscaling * Configure autoscaling as needed for your workload. Workers * Specify the number and type of worker nodes. Choose appropriate sizes based on your data volume and processing requirements. Click Create cluster. 3. Event Hub setup and connection string. 1. Get the Event Hubs connection string *. In the Azure portal, navigate to your Event Hub namespace. Click on Shared Access Policies under Settings. Choose a policy, example root manage shared access key. If you don't have one, create a new one with manage, send, and listen permissions. Copy the connection string, primary key, or secondary key. This is the connection string you'll use in your Databricks code. 4. Databricks Notebook Creation and Configuration. 1. Create a Databricks Notebook *. Asterisk in your Databricks workspace, click Workspace in the left navigation. Asterisk navigate to a suitable folder, example users/your_username. Asterisk right-click in the folder, select Create-Notebook. Asterisk name asterisk give your notebook a descriptive name, example Event Hub Streaming. Asterisk language asterisk choose either Python, PySpark, or Scala. Asterisk cluster asterisk select the cluster you created earlier. Asterisk click Create. Code examples. Here are code examples in both Python, PySpark, and Scala to connect to event hubs, read streaming data, perform simple transformations, and write the results. A. Python, PySpark. B. Scala. Explanation of the code asterisk. 1. Import libraries asterisk imports the necessary Spark SQL and streaming libraries. 2. Event hubs configuration asterisk. Asterisk replace the placeholder values with your actual event hub's namespace, event hub name, and connection string. Make sure to use the complete connection string, including the endpoint equals, part. Asterisk the event hubs.consumer group option specifies the consumer group to use. A consumer group is a view of the event stream. Using a dedicated consumer group for your Databricks job ensures that you don't interfere with other applications consuming from the same event hub. If you don't specify a consumer group, the default consumer group, $default, is used. 3. Read stream from event hubs asterisk. Asterisk spark.readstream.format, event hubs, .options, .load, Python, or spark.readstream.format, event hubs, .options, .load, Scala, reads the stream from event hubs using the specified configuration. Asterisk the .format, event hubs, specifies the event hub's data source. Asterisk the .options, Python, or .options, Scala, passes the event hub's configuration to the data source. Asterisk the .load, starts the streaming query. 4. Print schema asterisk df.print schema, displays the schema of the incoming data from event hubs. This is helpful for understanding the structure of the data and identifying the columns you need to work with. 5. Convert body to string asterisk the body column contains the raw event data in binary format. If your events are UTF-8 encoded text, example JSON, CSV, you need to convert the body column to a string using df.withColumn, body, df_body.cast, string, Python, or df.withColumn, body, $body.cast, string, Scala. 6. Parse JSON, example if your events are in JSON format, you can use the from_JSON function to parse the JSON data into separate columns. Asterisk you need to define a schema, struct type, that matches the structure of your JSON data. Asterisk from_JSON, col, body, schema, parses the JSON string in the body column according to the specified schema. Asterisk select, JSON data asterisk, include time, flattens the JSON structure by selecting all fields from the JSON data column and including the include time column. 7. Example transformation, aggregation with watermarking. This example demonstrates a simple aggregation to calculate the average value per sensor. Asterisk with watermark, timestamp, 30 minutes, defines a watermark for handling late arriving data. The timestamp column is used as the event time, and 30 minutes is the allowed latency. Data that arrives more than 30 minutes late will be dropped from the aggregation. Watermarking is crucial for correctness in streaming aggregations. Asterisk group by, window, timestamp, 10 minutes, 5 minutes, sensor_ID, groups the data into 10-minute windows, updating every 5 minutes, and also groups by sensor_ID. *ag, average, value, .alias, average_value, calculates the average value for each group. *output mode, complete, specifies the output mode for the streaming query. Complete mode is required for aggregations with watermarking because it outputs the entire result table on every trigger. 8. Write to console, testing. This writes the streaming results to the console for testing. Use output mode, complete, for aggregations. The truncate option controls whether to truncate the output. 9. Write to Delta Lake, optional. This demonstrates how to write the processed data to Delta Lake. *format, Delta, specifies the Delta Lake data source. *option, checkpoint location, /MNT/delta/checkpoints/sensor_data_ag, is required for streaming queries that write to Delta Lake. The checkpoint location stores the state of the streaming query, allowing it to recover from failures and continue processing from where it left off. Replace /MNT/delta/checkpoints/sensor_data_ag with a path in your storage account. *trigger, processing time equals 10 seconds, specifies the trigger interval. The query will be executed every 10 seconds. Adjust this based on your desired latency. Other options include once, to process all available data and then stop, or continuous, for low latency processing. *start, delta_table_path, starts the streaming query and writes the data to the specified Delta Lake path. Replace /MNT/delta/sensor_data_ag with a path in your storage account. This path is where your Delta Lake table will be stored. 6. Running the code and monitoring. 1. Replace placeholders. Make sure to replace all placeholder values in the code with your actual values for event hubs, storage accounts, and Delta Lake paths. 2. Run the notebook. Click Run All in the Databricks notebook to execute all the cells. 3. Monitor the streaming query. The console output will show the results of the streaming query as it processes data. You can also monitor the streaming query in the Spark UI. In your Databricks notebook, click the Spark UI link in the upper right corner. Go to the Streaming tab. You can see statistics about the streaming query, such as the input rate, processing rate, and latency. 4. Send data to event hubs. You'll need to send data to your event hubs to see the streaming query in action. You can use the Azure portal, the Event Hubs SDK, or a tool like Apache Kafka's Kafka Console Producer, if you have the Kafka integration enabled in Event Hubs, to send events to the Event Hub. Make sure the data you send matches the schema you defined in your Databricks notebook. 7. Best practices and considerations. Checkpointing. Always configure a checkpoint location when using structured streaming. The checkpoint location stores the state of the streaming query, allowing it to recover from failures and continue processing from where it left off. For production workloads, use a reliable storage system like Azure Blob Storage or Azure Data Lake Storage for the checkpoint location. This is especially important when writing to Delta Lake. Watermarking. Use watermarking to handle late arriving data in aggregations. Watermarking tells Spark how late data can be before it's dropped from the aggregation. Choose an appropriate watermark delay based on your data characteristics. Output modes. Choose the appropriate output mode for your streaming query. Append. Only new rows are written to the output. This is suitable for simple transformations that don't involve aggregations. Asterisk complete asterisk the entire result table is written to the output on every trigger. This is required for aggregations with watermarking. Use it judiciously, as it can be expensive for large result tables. Asterisk update asterisk only the rows that have been updated since the last trigger are written to the output. This is suitable for aggregations without watermarking where you only want to output the changes. Asterisk trigger intervals asterisk adjust the trigger interval based on your desired latency and processing requirements. Shorter trigger intervals will result in lower latency but higher resource consumption. Asterisk partitioning asterisk ensure your data is properly partitioned in event hubs and in Spark. Use the repartition or coalesce operations in Spark to adjust the number of partitions as needed. Asterisk consumer groups asterisk use dedicated consumer groups for each application consuming from the same event hub. This prevents one application from interfering with another. Asterisk error handling asterisk implement proper error handling in your streaming query. Use try except blocks or scalas try to catch exceptions and handle them gracefully. Consider logging errors to Azure Monitor or another logging system. Asterisk monitoring asterisk monitor your streaming query in the Spark UI and in Azure Monitor. Set up alerts to be notified of any issues. Asterisk security asterisk use appropriate security measures to protect your event hubs and Databricks workspace. Use Azure Active Directory authentication, network security groups, and encryption. Avoid storing connection strings directly in your code. Use Azure Key Vault to store secrets securely. Asterisk data serialization asterisk choose an efficient data serialization format like Apache Avro or Apache Parquet. This can significantly improve performance and reduce storage costs. When using JSON, ensure the structure is simple and well-defined for optimal parsing. Asterisk optimizing Delta Lake writes asterisk when writing to Delta Lake, consider optimizing the write performance by asterisk using optimize and vacuum commands regularly to compact the data and remove old versions. Asterisk partitioning the Delta Lake table based on common query patterns to improve query performance. Asterisk using Z ordering on frequently used columns to optimize data skipping. Asterisk cost management asterisk monitor the costs associated with your Azure services and optimize your configuration to reduce costs. Consider using reserved capacity for event hubs and Databricks to get discounts. 8. Sending data to event hubs. To generate data for your event hubs, you can use various methods. Here's a simple Python example using the Azure Event Hub library. 9. Conclusion. This tutorial provides a comprehensive guide to real-time streaming with Azure Databricks and event hubs. By following these steps and best practices, you can build robust and scalable data pipelines for processing real-time data. Remember to tailor the code and configuration to your specific use case and data characteristics. Good luck.